right, so here we're going to convert. In this one, we're converting from exponential to logarithmic form. Very useful when we're trying to solve these things exponentially. And then later on here, we're going to evaluate, and we are going to solve. Okay, so I should probably pull out my calculator. Just 1 second. Okay, so as my calculator here is loading, we'll just go through the first couple here before we get to the evaluate part. So we want to convert the following into exponential form. So remember, you could draw that little 7. So you start at the base, go up to the 9, and then you go across. That should say 3 to the power of 9 is equal to 7. Or, sorry, x. Or we could do this little switcheroo. Like I know these are going to have to switch. The base is 2. X is going to come to the other side, and the 8 is going to drop down to the other side over there. So you could draw the 7. Or you could just say that these two things are going to switch and the base stays the same. So this is base 4. So this will also be base 4 down here. So this is base 2. And this is base 5. So it was equal to 2 before. Now the 2 is the exponent. And the y was over here inside this operation. Now it's outside the operation. So that's the answers for those ones. Here can convert the other way. So, the base is base 3. So this is going to be a log base 3. And these guys are going to switch like they did before in the exponential one. There's no little 7 there, but it's a pretty easy little thing to try to remember here. So this x was in the exponent. It's going to switch and go to that side. And the 27 is going to go in. So it's going back. So log base 4. That's why I like to keep the log and the exponent on the same side, so I can see where everything is dropping down to here. So here's the 5 is going to drop down. Got log base 3, got a y there. This 5 is going to drop down, right? And then I got a log base x, 32. This is going to be a log base 4. X is going to drop down, and the 64 is going to go in. And there you go. Okay, so these ones you want to evaluate. There's a couple of ways to do this. You can think of this as, sorry, not evaluate. Which is, did I miss? Yeah. You can write these as exponential form to maybe start off with and see maybe I could just solve these without using a calculator or my best ability. So like if I were to draw this out, this would end up being x on that side. So that's good. We got the x by itself. And this becomes 3 to the power of 4. So x here would be 3 times 3, which is 9. And 3 times 3, which is 9. Then 9 times 9 is 81. So I believe that would be 81 there. Okay. And this one here would be m to the power of 4 is equal to 81. Then you think, okay, how do I get the 81 here? Well, the 81 will, if I take the 4th root here, so take the 4th root, ends up being 3. Now, because this is an even root, there's probably a positive, negative answer. I'm not too really concerned about that. We always just like to keep our bases positive when we have exponential functions anyway. But you could have a negative here. Okay. So this one's going to be x to the power of 3 is equal to 1,000. So I just did the little 7 there. Take the cubed root, get rid of that cube. This ends up being a 10. Okay, so not too bad. So far I haven't used a calculator yet, so this is going to be 2 to the power of 5 is equal to x over 2. Okay, now 2 to the power of 5 I don't know off by heart. So I pull out my calculator, 2 to the power, so let's get rid of this first. 2 to the power of 5 is 32. Okay, so that's 32. Then you're going to rearrange that. You're going to multiply both sides by 2 and get 64. There we go. This one's going to be 3 to the power of 5 is equal to y. So these guys are going to switch their spots. What's 3 to the power of 5, though? 3 to the power of 5 is 243. Okay. And this last one here, 2 to the power of 5, which we just discovered was 32. And these are going to switch their spots. So all of that 4x there is going to go to this side now. And then we're going to divide by 4 and get 8. There we go. Pretty cool. Okay, these last few here, we're just going to evaluate these. Now, there's a couple ways to evaluate them. You could change them into exponential form and then think, how would I do this? Or just plug in your calculator. Like nothing stops you from using your calculator at this point. So here we want to go log base 10. Then we can go alpha window, or you hit math and go down to the bottom, and then it says right down here at log base under the math here. So I'm going to log base, and then we're going to put our numbers. Now, if you don't have one of these newer calculators, you can't do this. So I'll get 3. So here, x is equal to 3. If you can't do that, you could do it this way, where you go log 1,000 divided by log 10. What's a log base 10 anyway? So I could have just went log 1,000. Because it's base 10, if I don't write it there, that's automatically base 10. So that should be 3 as well. Okay, so let's try this one out here. So I'm going to do this the old-fashioned way. So if I have a log base 11, 121, I'm going to go log 121 divided by log 11. So log 121 divided by log 11. What you're going to do is you're trying to keep it as precise as possible. So you're not going to write some decimal out and then round the answer by accident. And you might get something different, like make it a 1.99 when you should get like a 2, exactly 2. So this one, you do the same thing. You go log 27 divided by log 81. Okay, so you might get a fraction. That's fine. Let's see. Yeah, we do. If I go math, I try enter. Yeah, 3 over 4. It's equal to x. Like, again, you could just went alpha window, went down to log base, and just put the numbers in, like 81, 27, made it look exactly the same as that, and you get the same number. Okay? So log 128 divided by log 32 for this next one. You get 1.4. I'm just going to leave it as 1.4. There you go. Cool. Let's check out these next ones here. Solve for n. Yeah, so these ones are just going to change into exponential form if you can. So it would be 3 to the power of 5 is equal to n. So these guys are going to switch their spots. We could draw that little 7. And 3 to the power of 5, I think we did this already, is 240. Yeah, 243. Right? This one's going to be a to the power of 4 is equal to 256. So these guys are going to switch. But now to figure out this one, we're going to take the 4th root. So math number 5. Okay, so if you have one of these newer ones, you can do that. Math number 5. Oop, it says answer. So you want to put the number first. Oh, sorry about that. So I want to take the 4th root. So go 4, math number 5. So you see it puts a little 4 there now in the little index spot. And go 256. And you have 4. So A, because this is even, is plus or minus 4, right? Because I could take negative 4. You gotta make sure it's in brackets though. And I can raise it to the power of 4. So that's what you get there. And I don't know if this might work here. Let's see, I got a log. I'm gonna do a log base. Oh, this may not work. I don't think negative numbers will work actually. Let's see if that works or not. No, I never really tried. I have a different negative base here. No, it's going to give us a problem. So the negative 4 is going to be a problem here. So I'm just going to get rid of my negative 4s. Can't take the log of a negative number, so my base can't be negative here. So that's my bad. I don't think I had any other problems there. Okay. Yeah, I never really tried to fix that again. Okay, sorry about that. In my notes here, I tried to put a negative before, and it caused a problem because I put a negative here. But I could see it causing a negative because if you do this the old-fashioned way, you would try to take the log of negative 4, and I know that's not going to work because you can't do the log of a negative number. I just thought the base could be negative, but it's not. Okay, so let's switch these here. So x is going to be 243 to the power of 4 over 5. So 243 to the power of 4 over 5. Okay, so we get 81. And the last one here, z is equal to, or z to the power of 3 over 5 is equal to 8. Okay, so there's two ways to get rid of this exponent. You could take the 3/5 root of 8. You could do it that way. That's fine, right? Or you can kind of flip the exponent. That's a little bit tricky to do. Like if I want to get rid of a cube or to the power of 4, I take the 4th root. If I want to get rid of a cube, I take a cubed root. So if I want to get rid of this exponent, I just take that root. So what I'm going to do is I'm going to try to put this in brackets. Math number 5. Did that work? Yeah, it does work. Okay, cool. So we get 32. There we go. Okay. Hopefully that answers a bunch of your questions, and I will see you in the next video. Bye.